All right, I made a change on the assignment sheet. Did you guys even notice it? Probably not. What was the change, John?
Well, you switched one of the assignments.
No, I didn't.
I'm just kidding, you switched the test date.
Yeah, I switched the test. You know why?
I looked at it.
Why did I switch it then?
It's because there's only 2 sections.
Yeah, because I added another.
Yep.
So there's going to be 3 sections on this test, 7.1, 9.1, and 9.4. Okay, last night's homework. Any questions?
Yeah.
Okay, shout them out and I'll write it down. Go!
Wait, hold on.
99, 101.
99, are these the word problems?
Yes.
Yeah. And? 89. And 90 what? Aren't those all the word problems? And didn't I do one of them for you yesterday? Yeah. And what? Well, I thought somebody said 95, and that's the one I didn't. I'm ready to go berserk. All right, let's do this. Okay, 7.1. So you guys can do the ones where you just have to plug into the formula.
Yep.
Thank goodness. Okay, number 89. What do we got here? Movement of a minute hand. A minute hand of a clock is 6 inches long. So we have a clock. Okay, the minute hand is 6 inches long. How far does the tip of the minute hand move in 15 minutes? How far does it move in 25 minutes? Round your answer to 2 decimal places. Okay, let's do 15 minutes. Okay, let's say the minute hand is up here. It doesn't matter where it is. In 15 minutes, where would it be?
90 degrees.
Huh? I'm not doing 89? What am I looking at?
Yes, 89.
Oh, I'm looking at 91. But 91, 91 is there.
I thought you said like we're not doing 89, but 89 is on the board.
Okay, 89. I did one just like this yesterday. Ooh, this is 12 yards. That's 70 degrees. Find the length of the arc.
Oh, that's
Okay, so which formula am I going to use? The S equals R theta 1 or the area equals 1/2 R squared theta 1? This one, because you have to find the arc length, right? So the arc length is simply the radius multiplied by the angle in radians though. So you have to convert that to radians. How do you convert 70 degrees to radians?
180 over pi.
No, that's how.
Pi over 180.
Okay, if you don't know, what did I show you yesterday? What did I do? Dimensional analysis. So 70 degrees. How do I convert that to radians? You need to cancel out the degrees. So you need to put the radians on the top. See, the degrees cancel out and you just get radians. And what's the conversion? Pi radians is equal to 180 degrees. That's like multiplying by 1. So there you go. And then 10 goes into that. 10 goes into that. So you get 7 pi over 18. And I guess they want you to punch that in on your calculator, yeah?
No, we just leave it like that.
No. If you're going to not use your calculator, you got to reduce, because can't 6 go into both 12 and 18? 6 goes into that 2, 6 goes into that 3, so we got 14 pi over 3. So if you're going to leave it like, you know, without decimal places, then that's the way you do it. And then what are the units on this?
Yards.
Yards. Yards. Length of that. Remember now, both of these formulas, the angle has to be in radians. Okay, 91. Where's 91? Okay. 15 minutes. Okay, so in 15 minutes, this is 6 inches long, right? In 15 minutes, wouldn't it be right there?
It's 90 degrees.
Very good. How far does the tip of the minute hand move in 15 minutes? Come on! So basically, aren't you just figuring out this arc length right here then? Yeah. Okay, so how do you figure out the arc length? Now Chun said this is 90 degrees. Okay, so again, what's the formula? R times theta. So you take the radius and you multiply it by the angle measured in radians. Now, of course, we know this one, right? I hope. 90 degrees is how many radians? Pi over 2, and then if you want to go 2 goes into 6 3 times, so 3 pi is your answer. Now on this test, there's going to be a lot of calculator usage, you know, so you got to make sure you bring it and you got to start practicing with it. Tonight's homework is almost all calculator. And then the next night's homework is all calculator too, so maybe for this part I won't let you use your calculator, then you just leave your answer like this, so then the answer would be inches, yeah? Okay, next, 99. 99, what do we got? The diameter of each wheel of a bike. This is the kind you get on the SAT right here, yes.
So we just do the same thing for 25 minutes?
Okay, 25.
Sorry.
What, you want me to do all of it? Apparently. Okay, here. That's, okay, so where would 25 minutes be? Right there, right? So what you have to do, so the radius of the thing is still 6, you just have to figure out this angle now. Come on, look at the clock. Every 5 minutes is how many degrees? Look at the clock, it's back there.
Oh, 30.
Very good, it is 30.
It is
Every
30.
5 minutes
Hey,
is 30
every 5
degrees, right?
No. Dicks.
We're videoing here.
Didn't hear it.
So every 5 minutes is 15 degrees, so what do you think 25, what is 25 minutes gonna be?
Wait,
How
every
many
five-
degrees is that?
Wait.
If every 5 minutes is, what did they say, 30
You said
degrees?
15.
Whatever.
1.
Yes, 150 degrees. Okay, so the arc length is equal to the radius times the angle in radians. But 150 degrees, that's something from the unit circle, right? What's the radian measurement of 150? Oh my goodness. Okay, here's the unit circle. Here's 150 over there. So what's the radian measurement? 5 pi over 6.
6.
And even if you can't figure it out, just do dimensional analysis if you have to. But come on, that's right now for a unit circle. You have all of them memorized already. Look, the 6's cancel out, and you get 5 pi inches. Actually, to get 2 decimal place accuracy for the book, we don't need a calculator, do we? Because we know that pi is 3.14, right? Okay, just use the calculator. Okay, and then 99. What is 99? I gotta start reading again. The diameter of each wheel on a bicycle is 26 inches. So if the diameter is 26, what is the radius? 13 inches. If you are traveling at a speed of 35 miles per hour on this bicycle, through how many revolutions per minute are the wheels turning? This is exactly a physics problem, right here. Dimensional analysis right here. Okay, so what do we want to know? I am traveling at 35 miles per hour. That's why I assigned this problem. So that means if you're on the rim of the tire, that means this point here is traveling 35 miles per hour, right? But they want to know how many revolutions per minute is the tire making. So what we're going to do is convert this into revolutions per minute. This is a good exercise for SAT. Okay, so change miles per hour into revolutions per minute. Okay, now how do we figure that out? Okay, let's work on the time part. The time part is easy. How do you convert hours into minutes? Okay, look, here's hours. If I want to get rid of hours, I have to put it on the top like this so I can cancel it out, right?
60 minutes.
Okay, we got to do slow kind of. Okay, minutes then. Okay, so what do we know? 1 hour is equal to how many minutes?
60.
60 minutes. See, the hours cancel out and then now you get minutes. But they want revolutions per second, don't they?
Per minute.
Oh, they want it, okay, so we got the minutes. So now all we have to do is change the miles into revolutions. Okay, now, 1 revolution of the tire, what is that? If the tire just goes around once, how far did this point move? Just going around once. Isn't that the circumference of a circle? Right? Once around is the circumference of the circle. So 1 revolution is the circumference of the circle. And what is the circumference of the circle? Look at it. Circumference is equal to 2 pi r, which is 26 pi. So 26 pi inches now, this is inches now, is equal to 1 revolution, 1 time around it. You guys get that? Okay, so now what we gotta do is we gotta change the miles into inches then. Okay, now how do we do that? Okay, since we're filming, I can't go on to the next one. We're just gonna have to snake it then, even though I don't like that. So I wanna get rid of miles. Now how do we convert miles into inches? What do we need to do first? Okay, so miles, see how miles is on the top, you gotta put it on the bottom, miles and feet. Everybody knows that 1 mile is equal to 5,280 feet. What if you don't know that? Suffer! Okay, now we're gonna, how can we not know that? Like, don't you know there's 8 ounces in a cup? Hello. Okay. Everybody knows there's 8 ounces in a cup, right?
Yeah.
Because what if you have to figure out how many ounces there are in a gallon? What are you gonna do? See, now everybody had a chance. Okay, so cancel mile with mile. Okay, now we gotta change these feet into inches. Okay, so the feet is on the top, I gotta put feet on the bottom, inches on the top. So what do we know? 1 foot is equal to 12 inches. So the feet cancel out, so what do I have so far? Inches. But we know 1 revolution is 26 pi inches. So there you go. So you get the inches on the bottom and then revolutions on the top. So what do we know? 26 pi inches, which is the circumference of the circle, is 1 revolution. Bam! The inches cancel out, and what's left? Revolutions per minute. This is called dimensional analysis. When did you guys first learn this? Chemistry. Okay, you got it. Okay, so all you have to do, now they want you to use a calculator, so 35, do all the numerators first. 35 times 5280 times 12, and then you divide that by 60 and 26 pi. And if you have a calculator, that shouldn't be difficult, right? Well, we'll see on the test. This problem, what's the probability of this problem being on the test? Well, you know, if the problem's on the practice test, what's the probability?
100%.
1, that's right, 1. Okay, and then the last one is 101. So the reason why I assigned it is because you get this kind of problem on the SAT and the ACT. Maybe not the ACT so much, but SAT definitely. 101. Distance between cities. Memphis, Tennessee is due north of New Orleans. Find the distance between Memphis and New Orleans. Assume that the radius of the earth. Okay, now did you guys even draw a picture?
Always.
Okay, so here's the earth. Assume it's a perfect sphere, okay? So here is New Orleans. Wait. So Memphis and New Orleans, like this. Memphis and New Orleans. Okay. Here's the center of the circle. So the radius of the earth is 3960 miles, correct? Okay. Now in order to figure out this length right here, the arc length, isn't that the distance between Memphis and New Orleans then? We need to figure out this angle right there. In fact, this is good because it leads right into today's lesson. Now, how do I figure out what this angle is? Well, it says Memphis is 35 degrees and 9 minutes north latitude. Well, you guys know what that means? What does that mean? What do you think it means? Okay, what if you're in a prison And the only way you're gonna get out is you gotta at least know what this means. What do you think it means if you had to take a guess? Memphis is 35 degrees and 9 minutes north latitude.
I don't understand what you're asking.
Look, did you read the problem from last night's homework? It says right here, find the distance between Memphis, parentheses, 35 degrees, 9 minutes, north latitude. Now, you know what? I don't even know what that means, but I can take a pretty good guess.
The angle is 35 degrees.
Yeah, what angle?
The,
North latitude. What do you think that means?
is that angle?
North of the equator.
Thank you. North of the equator. So here's the equator like this. So if you measure 35 degrees and 9 minutes, like that, that's the angle right there. 35 degrees, 9 minutes. Now, before we even go further, do you guys even know what a minute is? Or do we need to discuss? Okay, we need to discuss that. Because if you don't know what that is, you get. Yeah, you're gonna have to know that for tonight's homework too. Okay, we have a circle. If I divide a circle into 360 parts like this, each one of these is called a degree. No, it's a degree. There's 360 degrees in a circle, right? So if I make 360 of these, each one is a degree, right? But if I take this degree and divide it into 60 equal parts, here, let me exaggerate. Let's say this is a degree, which is it isn't. But if I were to divide that into 60 equal parts, then each one of those is called
A minute.
a minute. And then if I took a minute and divided that into 60 equal parts, each one of those parts is called
Second.
a second. So when you measure an angle, you could have something like this, 42 degrees, 37 minutes, and 54 seconds. That's just a more precise way of measuring angles. You're gonna see that on tonight's homework. Okay, so now we know what that is, correct? So, from the equator, if I go to the north, 35 degrees and 9 minutes. See how they give it in, see, like if you're doing surveying and math things, they always give it in minutes and seconds. But nowadays, in the days of calculator, you know what they do? They just go, okay, 35.375 degrees or something. That's easier to punch in than your calculator, right? So does everybody understand from the equator? You go 35 degrees and 9 minutes north. Okay, so that's where Memphis is. Now, okay, what number are we doing?
101.
Oh, 101. What about New Orleans? 29 here, I'll write it up there. So Memphis, this is Memphis. New Orleans is 29 degrees, 57 minutes north latitude. So what does that mean now? Anyway, let me ask you this. If you didn't know what that meant on your homework, what do? Just go to the next problem. How about Google it or something? Don't you guys have things on your phone that you can do that? See, like my phone cannot, but your phone can, right? So, from the equator to get to New Orleans, you measure off okay, so here, why don't we draw this in? Okay, here's the equator, look right there. Okay? So to get to Memphis, I gotta go 35 degrees and 9 minutes north. To get to New Orleans, I gotta go 29 degrees, 57 minutes north.
You just subtract.
But I need to know this angle right here. How do I get that?
That's the difference.
Yeah, you just subtract, right? Because isn't this angle the big angle minus the small angle?
Yeah.
Some of you going, what? Okay, let's go back to geometry. If I know the whole angle here is, give me a number, 60 degrees, and this angle, just this angle there is 20 degrees, then what does this one have to be? 40, right? Same principle, you subtract, right? So, how do you subtract these angles? 35 degrees, 9 minutes, 29 degrees, 57 minutes, and we need to subtract them. How do I do that? What do I do? Mr. Park, 57 is bigger than 9, how do I subtract? You gotta borrow. You gotta borrow. Okay, so what you gotta do is you gotta borrow 1 degree from here. So change the 35 to 34. But 1 degree is equal to how many minutes? 60. So you gotta do that. You gotta add 60 to it. That's borrowing, right? Now can you go 69 minus 57?
No,
Yeah, what is it?
12 over
12. And then what's 34 minus 29?
5.
5. So 5 degrees, 12 minutes. So this angle that we want is, what is it? 5 degrees and 12 minutes. Okay, so to figure out this arc length here, arc length is equal to what? Radius times the angle measured in radians. Okay, so what is the radius of the circle? Well, they told you the radius of the earth is 3960 miles. But then you gotta multiply it by this angle in radians. Now here's the problem. Okay, so here we go. 5 degrees, 12 minutes. But you gotta convert that to radians. How do you convert degrees into radians? We did it like 3 times already. We're not gonna do dimensional analysis again and reinvent the wheel. You multiply it by
Pi over 1.
pi, thank you, pi over 180. See, hopefully by the 3rd time you get it. But now, how do you punch this in on your calculator? Mr. Park! Now, everybody take out your calculator, because you're going to have to know this. Tonight's homework, you got to do this all the time. Mr. Park, how do you punch in like minutes? And seconds? Okay, on your calculator, look for a button that looks like this. Degrees, minutes, and seconds. Look for it somewhere. Have you ever used it before? You don't even have a calculator!
It's just for today.
I can't remember if I took my blood pressure medicine. I hope I did. I might pass out. Okay, you know what? I'm just going to tell you, okay, did everybody find that button? But then you got to know how to use it. You guys even know how to use it? The last time I used that button was when I was in high school. So I kind of forget how to use that button. But I'm going to just teach you the way that it doesn't matter what calculator you have. Okay, like, how do you punch this in on your calculator? 42, that's 42 degrees, plus, now, how many minutes are in a degree? 60, so you got to punch in. This is 37 minutes, so you go 37 over 60. That's how you punch it in. Plus, now you got 54 seconds. How many seconds are there in a degree? 3,600, that's right, so you gotta go plus 54 over 3,600. That's how you punch it in on your calculator. That makes sense though, right? So, how do you punch in 5 degrees and 12 minutes on your calculator? You would have to punch this in as 5 plus
12 over 60.
12 over 60.
Well, so you don't even need to use the button if you do it like this yet.
Yeah, you don't need to use that button. But then, look, 12 over 60, isn't that 1/5? Which is 0.2, so that's just like 5.2 then, right? Easy! That's 5.2. So 5.2 times pi over 180 times 3960, punch that in on your calculator and you get it. Since you guys have your calculators out. What was it? Ano yun? That can't be right. You mean the distance from Memphis to New Orleans is what did you say? 0.0
No.
something miles?
359.
So I can just jog there in like 5 minutes. Okay, that makes more sense. So again, what does it say? 2 decimal places? 350 point. Just punch it.
398.
Okay, now it's done. 350. 3. Okay, child. No sense. Young. Do I have to get my calculator? Okay, 359. Okay, does it say 2 decimal places? Okay, now I already told you already. I'm trying to train you. But it doesn't tell you how many. You just give 3. So what? 359.398 miles. Did everybody get that? You guys are gonna have to use your calculator on the next test. Okay, I'm glad we did this problem because that will clear up some things for tonight's homework. Because you know what, like I said, when you're doing surveying and map stuff, they always give minutes and seconds. Instead of going like 42.637 degrees. See, because that's just easier to punch it on your calculator. But if they give it in minutes and seconds, then you have to punch it in like that. They're not.
Like, you know how you do the pi over 180 thing? Like, could you change that 180 to like minutes if you had to?
No. This is just converting the angle to radians. It's like, because remember, this angle has to be measured in radians. Yeah. So that's like a totally different thing we're doing. That we're just converting it to radians. Okay, no wonder you guys don't like the word problem.
So much work.
Oh, then you guys not gonna like tonight's chapter then. Tonight's homework. Because you gotta do work. What do you think is in this class? Just have a holiday every day. Just tan in the sun.
And just like compared to the other problems.
Okay, what are we doing today? 9.1. Okay, 9.1. Solving right triangles. Okay, now tonight's homework, basically, you just gotta know Sohcahtoa, which we already know, I think. But we're gonna use it to solve problems, though. That's the thing. So, remember now, in order to use Sohcahtoa, you have to have a right triangle. Okay? Now, what you're doing on tonight's homework is you're solving right triangles. Okay, so in other words, they're going to give you certain parts of a right triangle, and then you have to figure out all the other parts. Okay? So, for example, okay, why don't we call this triangle ABC? Now, when you label triangles, I don't know if you learned this in geometry, I'm pretty sure you did, but capital letters denote the vertices of the triangle, right? The angles. Lowercase letters represent the sides. And side A is going to be opposite angle A, right? Did you guys do that in geometry? So side B would be over here. See how it's opposite angle B? And side C. So lowercase represents the sides, uppercase represents the angles. Okay, so every right triangle, or every triangle for that matter, has 6 parts. Right? It has 3 sides and 3 angles. So what they're going to do is they're going to give you like 3 out of the 6, and then you got to figure out all the others. Now tonight's homework is easy because they're all going to be right triangles. So when you have right triangles, you just use Sohcahtoa. Okay, so let me give you an example. What if they did something like this? Okay, why don't I give this, what do you want to call this? Give me a number. 4. And angle A is 37 degrees, 42 minutes, and 17 seconds. Now, if you're lucky on tonight's homework, maybe they just might give you 37 degrees. Okay, but you just never know. Okay, you got to be prepared for anything. Or if you're lucky, 37.3 degrees. Okay, find all the other parts of the triangle. So I don't know how the book wants it done. It doesn't matter. You can, to me, you can just put it in the picture, or you can make a list like this: A, B, C, A, B, C. It's up to you how you want to do it. To me, it's good enough if you just draw it in on the picture. Now, what do we know? We already know angle C is 90 degrees, right? This is the right triangle. We know angle A is 37 degrees, 42 minutes, and 17 seconds. Okay, and we know sides, this is C, right? Because it's opposite angle C, is 4. So you're given 3 things, you gotta figure out the rest. Now how do you do that? Well, come on, if you know 2 angles of a triangle, what? How do you find the third? Since they all have to add up to 180. Yeah, so what you can do is just go 180 minus this, minus that, right? Or, you know, since it's a right triangle, these two angles gotta add up to 90, right? So this plus this gotta add up to 90. So how do I figure out angle B? You subtract that from 90. Now, how do you do that without a calculator? Like, if you have a calculator, you can do it. Without a calculator, how do you do it? 90 degrees minus 37 degrees, 42 minutes, and 17 seconds. Because right now, 90 degrees, 0 minutes, 0 seconds. How do you subtract? I just taught you 5 minutes ago.
I'm gonna borrow.
You gotta borrow. Now, how do you borrow? You gotta borrow from the degree. So right now it's 90 degrees. So if you borrow 1 degree, so this becomes 89. 1 degree is how many minutes? 60 minutes. But then also, I gotta borrow for the second. So I gotta take 1 minute from here, right? So change this to 59. 1 minute is equal to how many seconds? 60. So you gotta borrow. Now you can subtract. What is 60 minus 17? 43. You gotta borrow for that too, right? What's 59 minus 42? 17. And what's 89 minus 37? You gotta be kidding, there's no borrowing. Thank you, 52 degrees, there you go. So that's what angle B is. Put that right there. Or you can just put it in your picture, that's good enough for me. Okay, now here's the hard part. How do I find A and B? You gotta use Sohcahtoa. Now this is the kind of problems you see on the new SAT and the ACT, so you gotta be able to do it. Okay, so you know what this angle is right here. You know the hypotenuse. Which one you want to do first, A or B? Okay, let's figure out A first. So, in relationship to this angle right here, what is side A? Is it adjacent or opposite?
Opposite.
It's opposite, right? So which of the trig ratios has opposite and hypotenuse in it? And if you need to write it out, write it out. Sohcahtoa. Which of these three has opposite and hypotenuse in it? Look at it. Where do I see opposite and hypotenuse? Down right there. So that means I'm going to use sine. So the sine of 37 degrees, 42 minutes, and 17 seconds is equal to opposite over hypotenuse, which is 4. So how do you figure out what side A is? How do I get rid of this 4 here? Multiply both sides by 4. So side A is equal to 4 times the sine of 37 degrees, 42 minutes, and 17 seconds. Now some of you, if you guys figure out how to use the degrees, minutes, and seconds button, maybe that might help you. Just gotta figure out how to use it. Maybe you gotta Google something. So how do you punch this in on the calculator? Well, first of all, make sure your calculator is in degree mode, right? Make sure it's in degree mode, because that's the degree. Okay, so this is what you punch in on your calculator. 4 times the sine of 37, I just taught you 5 minutes ago, plus 42 over 60. I guess you're going to punch it in like this, not over 60, plus 17 over 3600. Boom! And then it's going to spit out the answer, and then you write it down.
Would you say the same thing for me?
Okay, you know what? I'm going to do it on my calculator and see if you guys match it. No, it's not the same for B because it's going to be a different trig ratio.
No, what I mean. No.
Yeah, this is going to be the same. So first thing I do is I make sure I'm in degree mode, which I'm not. See, I've got to change it. We'll go wrong. 4 times the sine of 37 plus 42 divided by 60 plus 17 divided by 3600. Kabam! And I get 2.446. Did you guys get that? On my test, you can give 3 decimal places, because that's how it is when you pre-calculus and calculus. So you take this answer, put it over there, or you can just put it on your picture, that's fine. It doesn't matter to me. Okay, now, how do you find side B over here? Side B. Okay, what is this side in relationship to this angle? This is adjacent, and you know, and you were given the hypotenuse. So which of these 3 has adjacent and hypotenuse in it? Look, which of these 3 has adjacent and a hypotenuse?
Cosine.
Right there, cosine. So you want to use the cosine ratio. So cosine of this angle, 37 degrees, 42 minutes, and 17 seconds, is equal to adjacent over hypotenuse. Here's adjacent, here's hypotenuse. B over 4. So how do I figure out what B is? Multiply both sides by 4, and you get 4 cosine 37 degrees, 42 minutes, and 17 seconds. Bam! Now, how do you punch that in on your calculator? You gotta go 4 times cosine 37 plus 42 over 60 plus 17 over 3600. Yeah! Okay, let's do that. 4 cosine 37 plus 42 over 60 plus 17 over 3600. I get 3.165. Did you guys get that? I see one person nodding. The rest of what, Lee? No calculator.
Yeah.
Okay, starting tomorrow. Did you guys take a picture of the book too? Remember what I told you yesterday?
Yeah, I got it.
Okay.
Right here.
We're gonna have calculator check. If you don't have your calculator, minus 1% of your quarter average for each button missing.
It's like 100 buttons.
Not more than that. Anyway, take this answer, put it there, or put it there in the picture. So when you do tonight's homework, all you gotta do is what's given, okay? And then you're gonna use one of these three. It's either gonna be sine, cosine, or tangent, so you gotta look at what's given. Okay, now, most of the problems on tonight's homework, they're all word problems, okay? So I'm gonna do a few. What time does this class end? 10. Okay, we got plenty of time. Okay, here we go. This is a flagpole, okay? This is a flagpole. I'm just making up problems right here. Our job is to figure out the length of the flagpole. I don't know what it is, okay? So what do? I stand at the flagpole and I walk off a certain distance. How much do I want to walk?
6 feet.
It's kind of close.
13.
Okay, 13 feet? Okay, whatever. 13 feet, okay? Now, so here's the flagpole over there. I walk 13 feet away. And then they have these instruments where you can measure angles. You know what this angle here is called? It's called the angle of elevation. Anytime you're looking up at something measured from the horizontal, that's called the angle of elevation. So we have instruments that can actually measure the angle. So let's say that this angle is, and since we're standing kind of close to the pole, it's kind of big, let's say 52 degrees, 52.7 degrees then. That's not degrees. Yeah. See, it's a lot easier if I just say 52.7 instead of giving you minutes and seconds. How high is the flagpole? Now remember, this has to be a right angle. Now, in order to use Sohcahtoa, it's got to be a right triangle now. So we have to assume the flagpole is vertical. Okay? So, here's the angle. This is the opposite side. This is the adjacent side. Which of the three trig ratios has opposite and adjacent in it? Where do I see opposite and adjacent? Right there! Tangent. So you want to use the tangent one. So the tangent of 52.7 degrees is equal to opposite over adjacent. This is easy. So how do I solve for x, which is the length of the flagpole? Multiply both sides by 13. Bam! There you go. Punch that in on your calculator. See, it's way easier if I give you decimal degrees instead of minutes and seconds. 13 times tangent of 52.7 degrees. Ta-da! And I get 17.065 feet. Is that? That's not that tall. There you go. So you just got to figure out, do I use sine, cosine, or tangent? Okay, next. We've got 2 more examples to do. Okay, now, angle of elevation is when you're looking up at something. Okay, so Mr. Park, since you have angle of elevation, is there such thing as an angle of depression when you're looking downwards? Yes. Suppose you are on a cliff. Okay, here's a cliff, and then here's the water, the ocean. Okay, assume the cliff to be vertical. Okay, so here you are on the top of the cliff, and you're looking at a boat on the ocean over there, like that. Okay, so let's say the height of the, let's say we know the height of the cliff. Let's say the cliff is, give me a number, 100 feet. Okay, that's a good sized cliff. 100 feet. And then the angle of depression is now, remember, whenever you compute an angle of elevation or an angle of depression, it's always measured from the horizontal. So here's the horizontal. Let's say the angle of depression is, give me something, 37.5 degrees. I'll just give it to you in decimals this time, okay? How far from the cliff is the boat? That's what I want to find. How far from the cliff is the boat? Okay, now, look at this right triangle. Do I know any of these angles? Yeah. Now, what do you want to do? You want to subtract it from 90 to get that angle? Or do you want to just go, that's 37.5, therefore this is 37.5. Remember geometry, if you have two parallel lines and you cut it with a third line, then these two angles are equal. So which one do you want to do? I think I want to do this one, okay? Because otherwise you subtract, well, if you have a calculator, it shouldn't be a problem. Yeah? So look at this triangle. I know this angle. What is this? Opposite. What is this? Adjacent. So which of the three has opposite and adjacent in it? Tangent. So the tangent of 37.5 degrees is equal to opposite over adjacent. Now, how do I solve for x? What do I do? First step, cross multiply. So x, some of you can do this all in your head at once, but let's go step by step. So multiply both sides by x, right? And then how do I get rid of this tan 37.5? Divide, so x is equal to 100 divided by tangent of 37.5 degrees. Okay, now we go to our calculator and we get 100 divided by tangent of 37.5 degrees. Cool! 130.323 feet. So the boat is 130.323 feet from the cliff, the base of the cliff. And again, we have to assume certain things. The cliff is exactly vertical. But in real life, it's not going to be exactly vertical. Yeah? Okay, now those are the easy problems. Now, are we ready for the hard problem? Too bad. We're doing a hard problem. Now in this class, this is as hard as it gets. Okay, what do you guys want to do? What kind of polygon do you want to do? It has to have at least 6 sides.
Octagon.
Okay, let's do octagon. Even that's kind of, let's do something weird. Nonagon. What about decagon?
Was that 10?
10.
Yep.
Okay, decagon. Suppose I have a regular decagon. Let me see if I can draw this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Could be better. Now, you guys know what a regular decagon means. That means all the sides and all the angles are equal, right? And what do you want to call the side? Give me a number.
4.
4. Compute the area. Compute the area of this decagon. Oh, how do I do that? Mr. Parker, it's hard. No, it's not. Look, here's the center. What if I draw this in? Oh, if I can find the area of this triangle right here, then can't I figure out the area of the whole thing? Because since this is a decagon, how many of these are there?
10.
There would be 10. So all I gotta do is figure out the area of this triangle and times it by 10, right? Okay, but how do I figure out the area of this triangle, Mr. Park? All I know is this is 4. I don't know anything else. Yes, you do, Moose Breath. Because look, what is this angle over here? How many degrees are there in a circle? 360, and then how many of these do I have? I have 10 of them. So
36.
what's 360 divided by 10?
36.
So that's 36. Yo, but Mr. Park, I don't even see a right triangle. Mr. Park, you only can use Sohcahtoa when there's a right triangle. Look, I don't even see a right triangle. So make one. how can I draw in a line? See, these are the harder SAT problems, yeah? How can I draw in a line to make right triangles? I'll give you a hint. How about right there? See, look, isn't this triangle right there a right triangle? And if that's 36 degrees, then what's half of it right there? 18 degrees. Oh, so Mr. Parker, this is 4. Isn't that 2 and 2 then? So, what's the strategy for finding the area of this triangle right here? 1/2 base times height, right? But I already know the base is 4, right? Isn't the base 4? All I have to do is figure out the height. Now, how do I figure out the height? Well, look at this triangle I shaded in. It's a right triangle. And look, there's the angle. This is adjacent, and that's opposite. Which of the 3 trig things has opposite and adjacent in it? See, that's why I tell you guys to write it out. Thank you, Toa, tangent. So, the tangent of 18 degrees is equal to opposite over adjacent, 2 over h. Can I figure out what h is now? Okay, can you guys do this? Can you guys just do this? H is equal to 2 over tangent of 18 degrees. Can you guys do that? Or do you have to multiply by the h first and then divide by the, whatever, just get that. So that's what the height is. The height is 2 divided by tangent 18 degrees. There you go. This is the area of this triangle right here. But how many of them are there all the way around? Look. How many of them are there? Rhymes with many. There's 10 of them. So you gotta times it by 10. And you can just punch that in on your calculator. Or if you want to simplify it first, like some of you go, oh, can't I cancel this 2 with that 2? Can't I multiply the 4 and the 10 and get 40? Yeah, you can. It doesn't matter. Once you write down the formula, all that matters now is can you get the answer. So let's look at our calculator now. So 40 divided by tangent of 18 degrees. Kaboom! 123.107 units squared. Because we're finding an area, right? It's going to be square units. There you go. So tonight's homework, if you don't have a right triangle, you got to draw in a line and make a right triangle because you can only use Sohcahtoa on a right triangle. And of course, what's the next question going to be? What happens if it's not a right triangle? Then that's going to be the next chapter. What happens when it's not a right triangle? Then we've got to use other things. All right. Oh, we finished just in time. Okay, tonight's homework is not going to be quite as easy as last night's homework now.
You gonna bring your book?
You really want to do that while the video is on?
Sorry.
Sorry. I'm sorry. Straight free kid. So if you guys don't like word problems, that means we're going to have to do a lot of problems on the board tomorrow then, huh?